Okay, I think we should be live on both platforms now. Let me just pull it up here. Live. Yes, get end of code day 10. Okay, looks good. Okay, we should be live right now. Let me just share the link on my socials quickly. So do come and we'll write streaming add code 125 day 10 in C#. And C# on twitch.tv/ntcss and boom. That is that. Let's also put it on the Discord like that. I should make the Twitch link clickable, but most people join on Twitch anyways. And then I'll drop it in this one here. Oh, what happened? Amarte, thanks for the resub. Thank you. Appreciate it. Very kind. Nice. Hello. Smab and Amarte are already here, so nice. I made myself a drink and I'm getting ready for today. So I have both a cup of tea and a cappuccino because it looks like today was gonna be a hard day. Well, usually I run out of my drink like an hour in, so with the last few days with everybody sharing their code, etc., it's been longer stream, so I thought I'd prepare properly. So sorry if you had to wait for a little bit. Amata says, I did it some time ago, but chat started reminding me to show every 30 seconds, so I had to press it. Okay. Yeah, that's what I said. Like, I think I said it a few days ago. I saw it in my statistics, but I never got a notification that somebody subs. And we just found out that if you don't press the show button, as a streamer, you won't see that somebody even subscribed. So you won't have a record of it. So you will see it in a dashboard where you can see earnings, but you never see it. So it's weird. Smab says, at least you finished by the time I got back last night. Yeah. Yesterday was fine. Let's see. So yeah, I went back to do yesterday's code because I had some ideas. I had something. I was thinking, like, if we go back to and let me pull this up here. Was there area? So just a quick flashback to yesterday's problem. When I saw this, my immediate thought was like, I should just look for the biggest one and run those first. And even when it's not this shape, like percentage-wise of the map, it makes sense to do the biggest ones first because the chance that you hit somebody is just relatively bigger to checking a small one. And for some reason, I didn't decide to do that till the very last because I was like, okay, maybe it's better to remember all the images I've drawn of like the test cases. So here, let me pull that up here. So my idea was then, okay, let's just make a sorted queue or like a sorted list based on how many times a line has caused a shape or an area to be voided. So yeah. So in this case, I would mark this line, and for the next shape, I would try this one first. And then you get another one, you add this also, so you would do these two first, the next time you try something. And I thought like that would give you the best probability because the ones that are clearly obstructing would get hit more than once. Amarte says, are you sure? Imagine how many big rects there are. If you remove rects there, you move center obstacle. Yeah, the thing is, like you're trying to make sure that a shape is valid, you have to test all lines on the map, right? Every one of those in here, you have to test them if you want to make sure that there is nothing interfering with your shape. So if the reasoning is you have to check all the shapes anyways, you want to exclude the areas as fast as possible. So if you take the lines that cover most of the map, you have a better chance of hitting large areas. So that was my reasoning, and I did something that did the weights one. So I made something, and I committed it, but I'm not sure if I have this thing here. So it would keep track of how many times you would hit, and then you have like an enumerator that will give you the ones that have hit the most first. But that added so much overhead that it actually got slower. So in the end, what I did for my day 9 was to just make sure that I sort them by taking the longest ones first. That reduces the runtime from like 9 milliseconds to 700 something. Marta says, so intersect biggest rect by the longest edge first. My logic is actually, it just looks whenever a line crosses into an area. So yeah. And that, I think I showed the bench before. Like that brings my part 2 down to 0.8 milliseconds. 0.8 milliseconds from being nearly 10 milliseconds before. So yeah, that is a very big jump. So, and I was happy with that. So yeah, I saw lots of people talking in the chat about how difficult today was. I have no clue yet what I'm about to encounter, but I'll start reading the problem set in a bit and see what today is all about. I saw people complaining about like giant allocations of memory and running code for hours and hours. So yeah, I'm a bit wary. So yeah, let's see. Boom. Day 10, factory. Just across the hall you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. Okay. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. For example, okay, complex input in 3 kinds of brackets. So we have angle, rounded, and then accolades. Okay. So also this one doesn't have... Okay, so this will be fun parsing out, but it's fine. It's one of these, and a bunch of these in the middle, so that should be fine. The manual describes 1 machine per line. Each line contains a single indicator light diagram in square brackets, 1 or more button wiring schematics in parentheses, and voltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram, where a period means off and a hashtag means on. The machine has a number of indicator lights shown, but its indicator lights are all initially off. Okay. So an indicator light diagram like this means that the machine has 4 indicator lights, which are initially off, and that the goal is to simultaneously configure the first light to be off, the second light to be on, the third to be on, and the fourth to be off. You can toggle the states of indicator lights by pushing any of the listed buttons. Each button lists which indicator light it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off, or turns off if it was on. Okay, so it's a bit flip, sure. You have to push each button an integer number of times. There's no such thing as 0.5 presses, nor can you push a button negative number of times. Sure, okay. So, a button wiring schematic like 034 means that each time you push that button, the first, fourth and fifth indicator light would all toggle between on and off. If the indicator lights were just the first one on, pushing the button would change them to be that instead. Okay. Because none of the machines are running, the voltage requirements are irrelevant and can be safely ignored. You can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. Okay. You could press the first 3 buttons once each, a total of 3 button presses. You could press the second button once, the fourth button once, and the last button twice, for a total of 4 button presses. You could press all of the buttons except that one once each, for a total of 5 button presses. Okay, however, the fewest button presses required is 2. One way to do this is by pressing the last buttons once each. The second machine can be configured with as few as 3 button presses. One way to achieve this is by pressing the last 3 buttons and blah 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 once each. The third machine has a total of 6 indicator lights that need to be configured correctly. Okay, the fewest presses required to correctly configure it is 2. One way to do this is by pressing buttons blah and blah once each. So the fewest button presses required to correctly configure the indicator lights on all of the machines is 7. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all of the machines? Okay. So part 1 is already pretty tricky in my mind. Because what you need to do, one of the useful things here is that sequencing doesn't matter. That's really useful. But what you do need to do is build out a combination of all buttons, and maybe even multiple of those, so that you can basically map every state. And I wonder if it's ever needed to push a single button more than once to get a desired outcome. I shouldn't have to think so. The first button 3, the first 3 buttons once, 3 buttons 3. Like, I don't think there is a solution that requires any button to be pressed more than twice, because but I'm not completely sure of that. First part is fine, see the second one. Actually, the fact that you click one twice, like the thing is, if you do it twice, you would toggle them on and off again. So what would change? Because if you hit the same button twice, it would flip twice back and forth. How would that change anything? Let me see again. You can toggle the states of indicator light by pushing any of the listed buttons. Each button lists which indicator light it toggles. Where 0 means the first light, 1 means the second light, and so on. When you push a button, each list turns on or off. So pressing anything twice would just go back to the same result. Am I crazy? I will have to model this and just look at it, because in my mind, when you say, okay, they all flip. Let's see, each button lists which indicator light it toggles. Because there is only on and off, so pressing any button twice would make 0 difference. So I must be missing something already. But yeah, let's just get on with the parsing, and I'll just write it out all, and we'll see you then. But yeah, this is gonna be fun. Day 10. I should prefix them with zeros. Okay. I split out sorry. I split out actually the prepare input into a separate one. I should probably do that here as well. Let me add that to day 0 and just do like avoid prepare input. So just to make it easy on the actual benches. Smap says, but yes, to get to the fewest presses, it's redundant. I don't know what you're trying to say. Like it should be irrelevant is what I'm trying to say, because pressing anything twice for like 2, 4, 6, 8, any even number of presses will have 0 impact unless I'm missing something, which is probably the case because they say it's required there. But we'll figure it out. We'll figure it out. Hopefully. So yeah, let's parse this out. Input 2 lines. Favorlop, welcome. Thanks for the follow. Happy to see you here in my Advent of Code stream. If you've done Advent of Code, feel free to talk about it. Tell me how your day went. I'm always curious to hear how other people's day went. So we do it 2 lines. I'm just going to write the parser now. I remove my helper using mkcss AOC. This brings back my helper, so I can do 2 lines. And then for each one of them, I can just do it for each for a string line in this. And then we do line that splits by ASCII whitespace is fine. That should trigger if there's more than one space, but it's fine. So I wonder if we could do it this way, but we can do it like this. String parts is this. And this requires an extension, sure. Or at least like this. And then we need to do our type. Let's make a type. So we have a public record. What did we call it? Also, I should record the test input here. So the answer to this one should be 7. Cons char light on y on target is this one. Um, what do we call these machines? It's just machines. Okay. Machine, light diagram, button wiring schematics, and jolt. Okay. Let's just try to get a little bit of theme going here. Machine. Okay. So this would be we could just do bool light diagram. We can probably use bit mask later on, something that comes to mind for like flipping the values, but I'll stick with bools for now. But I'm pretty sure Steve will have like bit masking, and maybe Amate as well, just to optimize the living daylight out of it. Let me see, wiring schemes. This would be it's basically a list of int, but and then Marta says, nah, it's old school. Joltage requirements. Ah, okay, I completely forgot what this does, so I will have to read back, and that maybe is my missing info for the buttons. So we do, this is also a list of int joltage requirements, something like this. Let me read it again. Ah, okay. This is your part 2 nightmare. Sure. Okay. I was like, I can't even remember what the joltage thing does. That's because he will slap you over the head with it later. We want to parse these out. So I will probably, I can do this, right? Public machine string raw, something like this. Must have a disk constructor analyzer. Ah, okay. So let's do it the other way of declaring it. So I can do public required like this. That also works. And now I can do this and just put it here. This means raw. So we will have the first one will be the light diagram. So we'll do for int I is 0 and len is this is diagram. And we actually do this like this. I smaller than len minus 1. because we want to strip out the angle brackets here. We don't care for those. If diagram I equals light on target, you can actually do light diagram now. This the light diagram equals mu bool. This is diagram.length minus 2. So we can do diagram I minus 1 equals this. Why? No, light diagram. So this is the mapping for which one should be on. Then we have the string joltage is parts. I can actually do this one, right? Does this work? Or will that treat it as... Ah, there's a from end. Wait, what? I should just do parts.length minus 1. This is probably the safest way, but I was curious to see what it showed there. And then everything in between will be the joltage lighting schematics, right? Wiring schematics. I can do English, me. The same here, except the for loop is on the parts, like this, and we do parts schematics is new list and boom. And the format, I should probably have copied one of them here. Like this. I think the best, actually what I could do is just wiring schematics.add, and this would be parts I, and then we do 1.1.split as in 32s, split, no, I need to split a comma, and then as in 32s. Well, so I take each one of them, I strip out the round brackets, and then I convert them to ints. Let me check the input to make sure that I don't need to go into bigger numbers. Now this is all fine. He says now, having no clue what's about to hit him. But yeah, I'm not gonna look at these scary numbers. There's plenty of time for nightmares later. So this is it parsed out. And now I should do override to string. Sure. So let's do string.join string.empty, and this becomes light select. This becomes, where's my marker? I had a const light on target, light off is this, we don't care, but it's fine. So we do light on target, light off. So this formats that part. Here we do string.join like this, and then we do wiring diagram, wiring schematics that select x string dot join comma x like this. And what this is, I haven't seen all of AFC or Chorus, but I don't recall any input that had a special part for P2 only. Yeah, this happened before, where it's like, oh, don't worry about it, we can ignore that and it will happen later. I'm a few accolades too deep here, probably. Okay, that's it. And then the last would be the joltage one. So joltage requirements. So this is also string.join, comma, joltage requirements. Okay, so this should be able to reproduce the stuff that goes in. Boom, 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 boom. I still need to parse the joltage, which is also this trick dot split comma as m32s, so I can do joltage requirements is this. So this is everything parsed out. So if not new machine line dot toString if yeah, there is a thing for that where you say, okay, everything has been set. What is it called again? Sets required members. Boom. I think that was it. So we can do machine m is new line. And then if not machine, do string, parse mismatch, blah, blah. Let's add this to make sure we have line and then m.toString. So, okay. Program, we need to start day 10. So let's see if a parser worked. Blowfish, welcome, greetings, fans of cephalopods. Cephalopods, yes. Space preservation. You're doing that to trigger me, right? Marta says, so last AUC ever will have a do not worry about it part in the input, and then it will indeed not be relevant to part 1 or part 2. That would be interesting. Who knows? Okay. I never instantiated this one, so we can do bloop. Let's try again. Okay, nice. They all mismatch. I have yes, my problem is the string formatter. I needed to do this. Let's run that again. Boom. Okay, so we can parse them, we can reproduce the exact string. This is for me just a nice and easy way to write a test to see if I parsed it correctly, because if you can reconstruct the exact input from the thing that we've parsed, it should mean that we parsed it correctly. That is part 1, so the parsing part is done. Now the annoying part. We need to have an internal state. So we should have state like this, and then we can do state is new bool like this. They all initialize, well, sure. Default state is off. And now we can add stuff to push a button. So we can do public void push and index. So we can do for each var toggle in blah index. It's fine. Hey Black Eye, welcome. So we can do this. That's state. We need to do a for I for. So we do take it locally. Var schematic is this. For int I is 0. I's len is the length count. I smaller len increment I. This state I is not. This is already a bug. Int index. Index is schematics. Oh yeah, I could have done a for loop. Never mind. Never mind. I can do a for loop. For each int index to toggle in this. This at state index to toggle is not this, okay? So this lets us push a button. Public string get state. Now we can just take this part here. Except we use state. State, not stage. Okay. So I would do something like public. Let's start with the void. Public void get possible states like this. Because I don't understand part of the program or part of the description that said you can push a button twice. So I'm going to actually emulate this first, just so that I know that I'm not crazy. I could take, is this the first one from the test input? I think it's that one, right? Blowfish Fugu says you could, but should you? Yeah, let's just do for once. Let's do what it says, and then we'll see. I think it's the first one, right? This is the first one. Okay, so if test. I never store the machines actually, so let's do a list of machines, blah, machines at m. I mean, if this is actually just a troll, like and I'm highlighting it off screen to troll you. If this is actually just a troll, I'll be disappointed. I'll be so disappointed in Eric. But yeah, let's see. I'm just gonna, just for fun, I'm gonna recreate what they say here. So var machine is machines 0, and we want to push 0, 1, 3, and then 5. Okay. Smap says, it's a troll, just explaining possibility. Notice the count is higher. Yeah, sure. Okay. But I'll still do it just to make sure that my button presses work and it produces this output, right? It's not a total loss, but Eric is still evil for doing this. So I can do machine console.writeLine, initial state, machine get state, machine. Let's do list int buttons to push is blah 1, 3, 5 for each. Int button to push and buttons to push. Machine that push button to push. After pushing blah, and this will be machine the diagrams button to push. I should call it buttons, but it's fine. So if we run this now, we get an index outside of nice. Okay, let's see what happens. Where is my error even throwing? It's nice that it shows. I'm in release mode still. I did that for the benchmark, so let's run it in debug. Let's see. Mizzy says, yo, good afternoon. Yes, welcome. Let's see, light diagram, button to push. Yeah. With the I need to, it was the wiring schematics that I need to push in. Wiring schematics, my bad. And this is a list, so I need to do string.join, comma, like this. Okay. Black Eye says, we're always asked to think outside the box, but out of bounds is a bad thing. Yeah. I was referencing the wrong thing, so okay, let's see. We have the initial state, we push the button, then we get into the state we want, we push it and we go back. So yeah, okay. Eric was just trolling with this one, but we have a functioning machine and we can do stuff. Sure. Now we need to figure out how to get to a certain state in the least amount of button pushes. So we need to have all unique combinations in all lengths. So we need to do light diagram get permutations. And we actually need to get every length. So we need to do for int I is 1 I smaller than wiring schematics that count, increment I. Boom. And we do wiring schematic, get permutations. This will be I, comma, allow dupe false. So this gives us every combination of all the buttons that you can push in any number. So you can push either every button once or not. Yes. So let's do, this would be a list of int. So yeah, list int unique combos is blah. So we do add range, and then we do like this. Is that not correct? It's a list of int. Jesus Christ. I should probably just get all the counts actually. So I could do like enumerator dot. There is a dot range thing like iter range. Numeral dot range. Okay, so we can do 0 to wiring schematics dot count. Okay, so we can do list int index is this. Okay, and then I can do indexes that get permutations, and the thing that we want should be this. Would that give us the proper target type? No. Yeah, because it's an iterator nesting thing, so that makes it more difficult. So console.writeLine. We have blah unique ways of pushing these blah buttons. Unique that's not a thing. Wiring count. Sure. I should probably do this one in my test thing here. So let's see if that works. 62 ways, 30 and 14. Sounds about right. So now we need to execute all of those, record their outcomes, and see which one of them is the least. And we should probably start from pushing the least amount of numbers. I'm fine, by the way. Yes. Sorry, Mizzy, I missed that one. So what we should do is sort this by the least amount of count, so that we try the smallest combinations first, record the outcomes, and then we should be good. So let's see. So let's do public void. I will think of the return time later. Map all outcomes. So we do var unique combos get possible states. Get possible button combos, sure. We do order them by order by because this will be a list int. Like this. So now we just produce all of them, and we will probably have like a dictionary of string. This is not the most efficient, but it's fine. And then we'll do the things that can produce this. Result is blah, return result. So now we do for each var combo in unique combos. We void reset state. Well, we can make this public. Public void reset state. Would it be faster to do this or just update every one of them? I could just do this. Boom. So let's see. We should do reset state before we do this, so we might do it one extra time here, but like you don't know what has happened before you call this, so it's best to be defensive about it and optionally call it once to many times. Vinny says, hi, I'm back again. Nice to see you again. Welcome on YouTube. Pleasure to have you as always. I hope you're enjoying today. If you've done Advent of Code, let me know how it went. I think for most people, judging from my Discord, it was pretty tough, so feel free to share your experience. Try to not give any spoilers though. So yeah, I'm just working on part 1 now. I'm doing probably a lot of work for nothing, but I think this is a nice way to hopefully help me prepare for part 2, but we'll see. Either way, I think this is pretty cool to build, even if it's a bit overkill maybe. Reset state, and then we do for each var button index in combo press. What was the push? Sorry, push button index. And then we do if not result try get value. Okay, string state is get state out var solutions is blah, result of add state solutions, and we do solutions that add combo. Boom. So this will give us every unique outcome that we can produce by pressing all those buttons, and then we just have to find the one that we want. That matches light diagram. So you can do public string as diagram. Now I can just do ask state, and this would be an array of bool values, and then we can do the get state thing. Where did I have that one? Boom. So this would be values like that. I might just want to do it like this, just so that it's something like this. So I can use this one for the pretty printing. Actually, no, I should probably just always do it like this, and then just make sure my toString thing works there. As state raw line diagram, something like this. Yes, I think that's better. That just saves a bit of memory here. So let me see, we were doing this, then we were doing this, map all outcomes, we did this to get the state. Yes. So now we can do this was our little test here. What we can do now is for our options is machine.get possible. Does it get possible button combos? No. Map all outcomes. Yes. Map all outcomes. So if options try get value machine dot line diagram. So machine that out for solutions, else console the white line could not solve. Boom. Solutions dot order by x dot count for each solution and this console the right line. We can get to blah, and this one would be string desired state is this. Solutions at count. So we will do a solution that count, and then we do string join solution. Okay, let's see if this works. We can get to this 4 ways. 2 presses, 2 presses, 3 presses, and 5 presses. Okay, that's cool. So if we do this, I think we solved part 1 now. We could press, and I don't have it mapped here, but this would map to index 1 and index 3. So that is this one. All of the buttons except for the total of 5. Why do I have more ways? That's interesting. There are a few ways. Machine. Okay, they just list a few. I actually found 4 instead of 3. Is that a bug? Who knows? But yeah. I'm interested now to see if this is correct. Just to make sure. We do machine.reset and then machine.push and we do solution. Yes. Or am I making myself it? That is probably, I should probably add another overload. Just that is fine. Let me run this again, just to validate. I mean, it should be fine, but yeah. Otherwise it wouldn't have been in that collection at all. But okay, so we have a way to do it. We can map all the combinations of things you can push. We can do that. I think we should probably solve it. So I can do like a public and solve, right? Which is basically the thing that we wrote here. So then the answer will be return like this. So we would do yeah, I should just comment all of this out. Part 1 is actually for each. I can do machines.sum m.solve like this. Okay, so I did part 1 and it passed. So let's put in the actual code to false. Let's run this. Okay, P1 475. Woohoo! First gold star. Yay. Okay. That was fairly easy. It was a bit of work, but it was pretty easy. Now I'm curious about part 2. So, just for myself, is this the same way you guys did it so far? Or did you take a different approach? Vinay says, what language do you like, prefer, and how many do you personally know and can comfortably program in? I know quite a lot. I prefer C# though, mainly. And then there's debate, like what is a programming language? Is regular expressions a programming language? Some will say yes, some will say no. It's programming adjacent, and I actually really like those. I have programmed in assembly, C, C++, Objective-C, PHP, Java, Kotlin, VB.NET, C#. I did a bit of Prolog, I did JavaScript, I did VB script for office stuff. I've tried so many languages, I've programmed in a lot of languages. And the benefit of trying other things is just to see like some of the coding conventions and things that are nice about other languages. But I prefer, like I said, try part 2 in Prolog. Yeah, it actually might be a benefit, but like constraint stuff. As soon as I figure out what part 2 is, but I'm kind of scared to click on it. But yeah, once you get to a certain level of proficiency in any language, and I mean any language, it becomes a lot easier to take all those concepts and apply them to a new language. Like there's always different types of base libraries, frameworks that you have to get used to, but in general, once you're really comfortable in one language, it's fairly trivial to move it to another one. There will always be challenges, like if you go from a managed language and you go to somewhere where you have to do your own memory tracking, like with Objective-C, where you have to increment how many things are looking at data, etc. That takes quite a bit of mental gymnastics to get used to, and the same for other unsafe languages, like the whole memory mapping and allocating and releasing it. That's something that you're not used to when you're writing C#, unless you're Steve or Amate. But yeah, basically you should be able to pick up any language at a certain point. Smap says, I think bad copy is about 6 hours into trying to solve this in Bash. So there are some languages that aren't right for the problem. Yeah, but she usually tries to she sets all sorts of extra challenges for herself, but she's pretty cool and always has like a unique approach. So she'll get there, I'm sure. She says, you're a goated person. Nah, man, there are plenty of wizards around. I just really enjoy programming and do it a lot, so I get better at it. So, yeah. And I'm happy that you're enjoying the stream. So, the moment I've been dreading. Let's look at what part 2 holds. I don't want to click it. Is that weird? I think this is the first time that I felt apprehension for continuing on the part 2. Lakai says, yes, he's been a whole day bashing, reading wikis, and implementing the math approach. Okay. Okay. I thought Bash Code was... who cares about product? Never mind. Let's just focus on part 2. Let's see what it actually is. All of the machines are starting to come online. Now, it's time to worry about the joltage requirements. Each machine needs to be configured to exactly the specified joltage level to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator light to increasing the joltage levels. Ignore the indicator light diagram. Okay. The machines each have a set of numeric counters tracking its joltage level. 1 counter per joltage requirement. The counters are all initially set to 0. The joltage requirement, like 3, 5, 4, 7, mean that the machine has 4 counters, which are all initially 0, and that the goal is to simultaneously configure the first counter to be 3, the second to be 5, the third to be 4, and the fourth to be 7. The button wiring schematics are still relevant. In this new joltage configuration mode, each button now indicates which counter it affects, whereas 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So a button wiring schematic like 1.3 means that each time you push that button, the second and fourth counters would increment by 1. If the current joltage levels were blah, pushing the button would change them to be 0, 2, 2, 4. Wait, what? The second and fourth counters would increase by 1. Okay. Yeah, sure. Yes. You can push each button as many times as you like, however, your finger is getting sore from all the button pushing, and so you'll need to determine the fewest total presses required to correctly configure each machine's joltage level counters to match the specified joltage requirements. Consider again the example from before. Configuring the first machine's counter requirement, a minimum of 10 button presses. Okay. Yeah, it makes sense because it's like it takes at least 7 here. One way to do this is by pressing this one once. Okay, I actually have an idea because you need to know the relative values between these. So all the outcomes, remember that I did a mapping of all the outcomes that you can do with this first part. And that's also why they make you do this, I think. I've mapped out the easiest way to get to a certain state. But that's toggling on and off. So now I would have to redo this and do it for absolute values. So not on and off, but absolute values. But if you do that same mapping, you can get every unique way in which you can increase all of these counters. So then you just need to find out how you can divide these by those. So I think that's doable. I just don't know the actual math on how to find like the division thing. But like getting into the proper aspects, if I can call it that, that should be doable. But yeah, let's see. Mindberry says, when I shortly switched into backup stream a few hours ago, I was watching a YouTube math tutorial to look for understanding. Okay, so I'm probably wrong because it's like, for me, it seems fairly easy. Well, not easy, but if you know all the ways you can get certain numbers, you at least can know which buttons you can push to get to a certain solution. I think. But yeah, let's see. I'm probably underestimating the problem. Configuring the first machine counter requirements, minimum sure. Configuring the second machine. Yeah. So this one is 33. Let's put in the test things here so that we can at least have the test stuff going. Let me also commit this first before I forget. Day 10 part 1. Boom. Push. Okay. Let's see. Test is 33. And the answer I had from the other one here was 475. Sure. Black Ice has just changed the logic of the press button to increment and let the PC to die. Yeah. Vinny says, any project you're working on currently, any projects you'd like to work on the future? Yes, I'm currently doing two major things. One is a content management system for customers. I'm running a web hosting company right now. And the other one is that I still need to finish this one, where you can share files with each other. One of the biggest file sharing sites that is used corporately in the Netherlands. And I think more of Europe is WeTransfer, and they had like an update that would let them scan all the data that you send to them for their AI machine learning things, and people didn't like that. And I built this tool a few months ago for my father-in-law because he has like a band that he does musicals, more like an orchestra that he does musical stuff for. So he has to change things and send them out to people. And I used to use WeTransfer, but he ran into their limits. And then this thing happened, and I know an artist who uses WeTransfer for her art, and she also would like an alternative. So I started to create this, and this just lets you upload a file and share it that way without it being on like big American servers that people in Europe try not to do, etc. So this is something that I still need to finish. It's pretty much set up, but I still need to put a few finishing touches on it so that it's that's done, and I can actually charge people for it. And I will also use that to as like a freebie for the lowest tier for all my customers, so that I can have some testers for that as well. Like I said, my father-in-law already used it, but he will easily glance over any small imperfections. So I think that is fun. So currently I'm just working on my web hosting company. Let's see, where was I reading? Configure a third machine counter requires a minimum of 11 button presses. Yeah, sure. Analyze machines. Okay. So this needs to, I wonder if I should fork this, because either I have to have a split mode, or so I think for now I'll just, do I want to do this? Let me think. How big were the numbers for joltage? It's like the biggest number in there. They're all fairly doable, like below a byte. Okay. So yeah. Because I was also thinking, like, you could make this like a pathfinding problem and just use a priority queue probably, but given the fact that everybody is running out of memory and time there, makes me think that that's not the option. So I think it should be like a proportional thing, maybe. But then finding the proper strategy to get where we want to go. So I think like you have to do something to look at the largest numbers, find a way to get there in a safe way, and then find a way. It's tricky. It's tricky. Let me see. I'm just still debating. I could like do public bool. I could add that to the push thing. I can do that to the push thing. Spam says, you're welcome to try the hare versus the rabbit. Well, I know, probably lonely by now. Yeah. Let's see. Oh, that's not it. So these can be bytes. I don't need more than that. Not that it really matters a lot, but it's fine. So I also need to change this one. Full jolt is false. I'm just gonna do it like this. Push joltage, joltage. Like this. So this then becomes map all joltage outcomes. No. Yes. How many buttons are, I mean, no, it can never overflow there by just having all the button combinations. So we have that. We can reset state should also reset the joltage thing. Come on. Bum, 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 bum. Actually, no. Let's keep it separate. In this case, does it really matter? Because you only want the most efficient if it's the same outcome. Byte voltages. Something like this. Let's see. So like this. And this should be refer to the local one, right? Okay, so we use this just as a unique key for now. Come on. And then solution like this. That should be fine. Like this. Basically this one. Okay. And then we need to push voltage. Vinny says it takes a lot of time and patience to solve these questions and stay a sane person. Yeah. Especially when time goes on. And right now, I still have like an idea of what I want to do. The trouble begins when you either don't have a clue of how to solve it, or when you've encountered a bug or something like that. So far, I'm still fine, but I don't know how long this will remain. So sure, that's all the voltage outcomes. I think this is fine. So let's see, if we go back to this case, now we want to do the test for part 2, which we will take this code for, because that works pretty well. So we take all voltage outcomes. We can't get the desired state. We first need to get every combo out there. So we do for each var option in options. So we do console.writeLine. We can achieve blah in blah ways. Blah. So this is option dot solutions dot count. This will be string dot join comma, and this will be option dot voltages. And here we will do string dot join option dot solutions dot select x dot string dot join block. Okay. So let's go back to the test input and see if this part works. Okay, it spit out a bunch of stuff, so that is fine. So this is for the first machine. Okay, let's see. So what did we learn? For the first machine, we can figure out which things we can increase for each one of those states, because these are like all the unique combinations of how to increase, right? With the accompanying buttons. So we know we can get 2 here by pushing this one. In the end, though, you probably want to increase the most with the least buttons, but then you will also want to use the most efficient way to get there. So now you're getting into like constraint solving theory. This is what a quantum computer would be great at, by the way. Smap says, the good news, it's fairly easy to get a test to pass. Yeah, I just hardcode the solution and I'm there. Let's see. So the thing is, you will probably want to figure out what the most efficient way is to increase the numbers. And this is kind of like something we did before, but like here the efficiency is also like 2 per button. Here we have an efficiency of 2 per button. 3 and 2. So let me give an efficiency score to each. Our best is not, is this ordered? I think so, right? Maple voltage outcomes. No, this is not ordered per se, so what we can do is dot order by dot count first. So now we don't do this, but we say like this. And this would be option dot sum dot jolt just dot sum. There's no way this is gonna. I can just do this. Sum divided by, and this also doesn't matter, pass or count. Something like that, right? Oh, I did my format string wrong. Let me see. Okay, format string needs to be inside. Marta said there was a problem like this 2 years ago. This one is just a small bit harder. Yeah, I can't just remember it. So the best efficiency is 2 here. There's nothing above 2. So my idea is probably that we should try to get all the way as far as way to the target using these 2 numbers, and then find a way to go back using the lesser ones, but who knows. I don't even know if it's possible to use to do it by using the most efficient ones. I'm just thinking about how can I now do this. Basically what I could do is I could use a priority queue to find these, I think. Let's just try it. Let's see. So public int solve voltage priority queue. Kenny says, sorry, I'm not able to be of any help. I'm not good enough to understand this, but I'm here to chill. Sorry for my random. No worries, don't worry about it. I'm happy to have you here. It's always nice to have people in chat, even if they just hang out and say hi from time to time. So no worries at all, just happy to have you here. So now what I'm going to do is we have all these combinations. These are basically our options. So what I will do is I will do what I did here. Let me see. Basically this one, and reduce it to the best options, because these are the only choices that you can have, right? So I can do for our options is this. And then we turn this into a list of best options. So we list, and we don't even care about what it is. No, that's not true. We do care. It's a list of the byte array values that we increase by byte voltages, and this is int count, or best options, like this. Smap says, I'm pretty sure I have that one hanging out on a different Git branch somewhere where I failed to solve it. Let's see. Amarte, I can't tell you which one, Nick, because I remember you haven't done it yet, so it won't. Yeah, no worries, no worries, no worries. I have an idea, like my delusional brain still says that I can solve this, so just usually when you think you can, even when it's implausible, you might be able to do it. So yeah, let's just go for it. My thinking here is I don't even need to simulate all the things, because I already have the outcomes. I can just apply these changes and then keep track of this count. So I basically pre-computed all of the steps of actually pressing the buttons. So I think that's a big optimization there as well. So here I can just do best options.add, and this would be option.voltages, and then best.count. This is all that we need. And now we need a priority queue and just randomly track that, test them till we get to our end result. I think. And that might be highly optimistic, but let's see if it works. So let's see, priority queue. In this case, we need to have the state. So we have byte voltages, int count. Actually, this is all that we need. And then priority, how do I call it? This can just be long. It's probably not that long, but queue. Plug. That is fine. So our desired state, that means just sequence equals for this. Sure. So now we do q.nq, no, .nq. This would be a reset value for zeros. So reset voltages would be just a new byte of line diagram length. So we queue up this one with 0. And priority is actually 0. Do I even need to? I think I only actually need this. I don't even need to have the other thing because it would be the priority. Well, I'll just keep it in there. It's fine. Let's make it a long just in case. But I don't think it should matter that much. The queue here is long. Like this. While q.count larger 0. Now the thing, I think, yeah, sure. I think you put them all in and then you check. So on the D check is q.dq. So var candidate is this. If candidate dot jolted sequence equal this dot jolted requirements. Never mind, this can be a byte. Boom, jolted requirements. Then I need to change my parsing code here. And this can just be like, boom. That's fine. Okay. So that is that. Solve joltage. If the match found, return candidate. Okay, that is satisfied. For each var option in best options. And now the thing is, we need to make sure that we don't go over any of them. For int I is 0, int joltage okay. I smaller than this plus I. If candidate.joltages I plus option I larger than voltage requirements I. If and Q, Q that and Q. I should actually prepare the candidate there so that I don't do it twice. Byte candidate. Yes, voltage requirements at length. New candidate. New voltage. Okay. And then I can actually just do candidate voltages select X plus. That is annoying. And then we do K plus this needs to be inside the loop here. J plus option dot voltages I. What's the issue here? Why is it complaining? Voltages is not null here. I know. Okay, and I and index byte value I. Is it I? Okay, index. Never mind. Okay. It's probably not the most efficient. Now that I've written all of that out, but that is fine. So now we do if this one is further otherwise and Q, and here we do blah, and this is candidate.count plus option count. Like this, okay. Vinay says, where do you live? What time is it there? It's midnight here. It's 7:45 in the evening here. I live in the Netherlands. Okay, so we check here if we go out of bounds. If we don't go out of bounds, we add it here. We might also just check if it's the exact match here, but it's fine. I'll do that here. So. So I think this is already it. So let's see. P2 is machines.sum m solve voltage. So now I'm really curious to see if this works. Would be pretty cool, but my machine is blowing and not doing this. So let me see. How big is the queue? It's infinitely big. Cool. And how far along is the candidate? It's only 7 deep. So yeah, that's an issue. Is it test or live? This is the test, actually. Welcome to the party, yes. So BFS won't work. At least not my implementation. So yeah, just to reiterate, what I did is calculate the best options, which is all the unique ways to add values, which is 50 ways. You can have 50 different ways of adding values. Snap says, it worked for me for the test value. Yeah, it might, but I'm not even sure which machine I'm on right now. 2232. Which one of the tests is that? None. Oh, it's wait, what? False, false, true, false. Am I doing something wrong? Ah, it's doing this one here. But it also has the wrong voltage thing. So it did the first one. So it's funny that it updated this one, because this one should start at 0. So let me see, I'm doing something wrong somewhere. Oh yeah, that's just from all the testing. Never mind, never mind, never mind. Map all voltage outcomes. This one is also not correct. This one needs to be 0. Let's see, for each combo, unique combos. I'm doing something wrong here, aren't I? Oh no, never mind. No, that's fine. I just don't reset it after the first time, so yeah, that's fine. So if I let this run, it will probably spit out something in the end, because it managed to do the first one, but it had so many combos there. I should probably also, it does a lot of work twice, so every combination of buttons also doesn't need to get rechecked every time. So that is one of the issues that I have. Every unique combo of buttons isn't that unique. So I should probably be able to cache that state. That is something that I need to do. I need to cache the state. So I probably need to have like the hash set of the buttons that is pressed as a key and then cache that. So let me just do that as well. So I can do that. So this queue, this becomes a hash, no, not a hash set, a list of yeah, it needs to be a dictionary actually of int options explored. All right, and this one needs to be turned into a key. So let me think. Vinay said you should just ask an AI agent. That's what current developers do in corporate jobs. Yeah, but what's the fun in that, you know? So what I need to do is cache these so that we don't have to do that. So I would have like a dictionary of string, which will be my key of all the combined values, and the value would be then this options explored, byte, jolted, just, and int count, long count. Cache is this. Okay. Because the order in which it is pressed doesn't matter. The amount of times does. Let me see. So this is now the joltages. I can do blah for the new dictionary. And then why doesn't it like this? Collection, expression, long to byte. Okay. So I need to be explicit. Like this. Okay, why doesn't it like this? Ah, never mind. This is long options. No, options of like this. I had the thing the wrong way around. Count. Now I should be able to do this. Okay, took a while, but we got there. Now I just need to do this in a different way because I need to create a key out of what we did. So and I need to know how I can actually use this cache instead of adding it. That's also one of the things that I need to figure out, because I can cache a bunch of those. Or no, actually I can just skip the ones that we've seen before. That's more logical. So yeah, we can do need to describe the key first. So first you would have to do this local options explored is option dot option no. Yes, candidate dot options explored like this. Must have an add a single arm. Okay. That's annoying. We should It's annoying. So I could do does that work? Does that clone it? Not sure. We'll figure it out soon enough. Local options explore dot add. If not, local option try again value option dot. And I don't know the end. I need to do this by index just so that it doesn't blow up. So I need to do for int I is 0, I smaller. So I do int option count is best options dot count. I smaller best option count increment I. Then we need, let's see. We do this thing. Var option is best options I. We clone this one. We try to get I out option option count. It's great that I already have this name. Number of options. Okay, this will become int option count. We do local options explore add I comma I 1 else local options explored I equals option count plus 1. Something like this. Then we need to make a unique key out of this. String key equals blah, and this becomes local options explored dot keys dot order by x. Which is fine. And then we do a select so this then becomes x followed by local options explored x, and then we need to join this. So we do string dot join comma this. This is basically our stringified key. So this will have a sorted count of every option we took with their amount. So this is a unique key, regardless of how, in which order the buttons are pressed, because that doesn't matter for our state. Let's see, and then we do if not cache try get value key out. And this is probably everything that we've seen, so we don't even need contains key. I don't think we actually need the values of the dictionary, just the cache here. If it's not, then we can try to add it. And so then we do this whole spiel. We call J here now instead of I. Always be aware when you do stuff like this, like explicitly numbering your iterators, like in your for loops, is always a recipe for disaster if you don't pay attention. So do as I say, not as I do. Let me see. DNQ, then we need to do local options explored. And then we do this. Let's see if this saves us a bit. Doesn't look like it. It's still producing a lot of combinations. This is 1,000,000, but so this is for 6-button press. There are so many ways already. So great. Let me see. Part 2. For each bar, machine, and machines. So let's see. Wow, it's gotten slower because it was working on the second one when I tested it. Jesus Christ. How nice. Gonna go for a quick bathroom break while you see if this one gives progress. I'll be back in a few. Huh. Okay, that's interesting. It didn't even spit out a single one yet. So there's either something very wrong, or my code is just really, really bad. Let's see. How does the cache look like? The cache has 0 entries. Oh, wait. Your break was too short for the algorithm. Yeah. This is smart, right? You build a cache and then you never add it to the cache. Key. And this would be local options explored. Candidate.joltages and candidate.count. I think this is what I wanted to track. Okay, so let's run this again. Okay, so if you look now, the queue is still very large. How does the cache look like? Okay, we got a bunch of stuff in the cache. So basically it should have like 50 entries for pressing them once, and then for 20, okay. So like the benefit is that it doesn't this works. I probably don't even need to cache the values, because for me it's just to skip, and it just adds a whole lot of overhead. So I could just do, oh, it's just a hash set of string, right? This becomes contains. This would be a little bit faster, but not very fast. The thing is, it's just still so many options. Oh, okay. It took a little bit of time to run, but then it worked. Luke says, hi, just joining, how's it going? First hour was easy? Yeah, first hour was fairly easy. And I need to fix my cache to make it better, and then it worked. So that's something. It's not fast. So that gives me very little hope for the second part. So just let me see if it works. On YouTube, we have, here's a good project idea. Make a video game to play for your children from scratch, like building your own game engine. Getting secondhand anxiety watching this not work. You're welcome. I actually made games for my children in the past. I made like a memory game where I used their own drawings, like when they were very little, like 3, 4 years old, 2, 3, 4, that range. I took their drawings and then I created a memory game where they had to find their own drawings. I really liked that. And like a game that learned them to type. So you would see a big letter and then you have to find it on the keyboard, and you get lots of nice feedback so that you know how a QWERTY keyboard works. I think those were the first easy games that I made for them. I made a Simon Says game. I don't know if I still have that on my phone actually. And I don't even remember how I named it. It had a different name. But yeah, never mind. Made a bunch of stuff, but let's focus on this first. I'm gonna run this for the real one and see how bad it gets. Boom. Arithmetic overflow. Wait, the requirements. Is there one that's bigger than a byte? Okay, let's see. Then what does exist in your current context? Locals. Exception. X is 285. Okay, so There are ones that are bigger than a byte, so I have to change all of this around. That's fine. So this one becomes short. A short, short, short. Do I have byte somewhere? Short, short. And everywhere I have byte, I now need to do short. Okay. Boom. Okay, I think that's all the errors. Let's run this again. Nice, none of them. Yep, actually none of them. How big is the cache? Cache is over 9 million entries, so the queue is also very big. Yeah, duh. I mean, there is a moment where it starts to shrink, but this is way too slow. So what I'm thinking is, remember when I mapped out the efficiency thing, what I could do is see if there is a way to get to a certain level with just efficiency buttons so that you know that you won't be doing extra stuff that you shouldn't have to. Okay, so this is clearly not gonna work. Boom. Let me see here. Like this one, I'm still interested to see. Okay. Let me just do this first. Vinay says, all right, man, it's time for me to sign off. I have my exam tomorrow. Oh, okay. Good luck on your exam and thanks for hanging out. And hopefully see you again soon. So thanks for stopping by and good luck tomorrow. Let me see. We have here our list of all the unique combinations. Here we have an efficiency of 8. Wow. That's nice. So my idea was like, is there a way to maybe find a button that we can push to get as close as possible to the desired outcome? And this is a bit of the issue, right? For this first one, this is the first. There are over 4,000 options for the first button there. And I think that most of that is probably irrelevant. Because I'm trying to explore every one of them, and that's an issue. Oh yeah, that is my problem. I'm trying to be too smart. I need to explore just the individual button presses. I'm an idiot. Sorry, I'm really an idiot. I'm making this so much harder than it needs to be. Because like all these are combinations of buttons. There are just 11 buttons. So for me, I've pre-calculated all the unique combinations of buttons that you can push, but that doesn't mean that is the right way to explore it at the start. Though, does it matter? Because like I started out thinking like, okay, you know, button 10 has an efficiency of 8. So if we figure out how much times we can use the most efficient button without getting in the way of all our other options. So that was what was my thinking, like, okay, maybe we can see how far along we can get there. Like you take for every button that the best option has. So like, let's see. So we can do options of order by descending. This, and this is X. Oh, and this is also still this, yeah. No. So we need to do options dot select x dot solutions order by descending first, and then we do that. Wait. Option dot joltages, so this one. Black Guy says my brute force solution runs on 10 megabytes but high CPU update. In this 2 hours it finished another line. Damn, 143 out of 199 now. Okay. Yeah. I think if I can do a trick to get us most of the way there, that we can find a way to do this. But I'm struggling with something easy now even. So my idea was to just get this list that I'm outputting and just sort of descending, but I'm just annoyed now. So I have these options and I select them. For each one of them we have solutions, order by descending x, y, count dot first. And then for these are like the top options. Var best options is this. Yes, it's a list of list of list. A list of int. Okay, like this. Never mind. It needs to be best is this. Like this. Jolted is like this. Okay. Yeah, so a list of this. Yeah, okay, like that. So this is the list of the best ones, but then we also want to get the efficiency there, and that's this part. And then we want to sort this. Blah. Order by descending. So this would be x at joltages. Like this. I should probably do another select. Marta says, Nick, do you limit your maximum possible presses for each button? If not, that would help, I think. I don't currently. I have a priority queue, so I order it just based on the amount of buttons, but it does round robin every time. So like for every step that you take, it adds another round of every combination. And that's probably also the issue, that I have too much options to get where I need to be going. So yeah, I can't do this here, but I can do this, like dot select x. Voltages, efficient. That will be this. Okay, why are we complaining? Because I don't have a value for that, so that would be double efficient. Okay, order by descending x of efficiency. Okay, so this will be our list ordered by best options. So now I can do for each var, come on, for each var option in best options, and then I can do this. So that was a lot of typing for a simple change of order. Yeah, let's see. If we go all the way back up here. Here, this one takes everything except this one. Okay. So my idea was basically see how many times you can use the most efficient one, or just use it like half the time to just get a head start there. So just to limit the search space by a lot. The other thing that I thought was to just limit myself to one variant. So this is just all me mucking about, trying to brainstorm a bit. Okay, I can do that. So if I do the solve joltage, the thing that I have is map all joltage outcomes. So I can do int cap null. Same here. Like this. Sure, whatever. So now what I can do is map all joltage outcomes, and I can say I just want one there. This one should be inclusive actually, now that I think of it. So this wasn't even optimized yet for every combination. So if I do this now, I'm curious to see if this helps with the search space, because I just limit myself there already and have more opportunity for the cache to work, but maybe I'm delusional there. So just gonna see if that works. Does it look like it's an improvement because it gets slower now? Nice, so I've managed to make it slower. That's also a skill, right? Let's see. Q, cache, Q. Actually, what's in the cache right now? Mm, 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 mm. Um, I wonder if I should add like an efficiency score there as well. But Leaks as well. I just found a lib that does this algorithm. Now P2 runs in 1.7 seconds. Nice. So now if I run this again, is it in like a second? Let's see if I manage to get back to where I was. I had this working for the test, right? Oh, this isn't a test. Never mind. This isn't a test. Never mind. Let me run this again. It should do like bloop bloop. Okay. And if I limit this, test is true. Let's see, solve the joltage, solve joltage outcome. If I limit this to 1, does that improve anything? Yes, okay. That does make it faster. Okay. So that means not much, but like I think the answer is partly with the cache. I'm just thinking like what else can I cache, because I'm pretty sure that having a good caching strategy is very important. Also, having a way to skip a lot of this is very important. So like what I'm wondering is if I could, like for this case, okay, not this one here, okay. What I could do is look at the lowest number, take the most efficient button press, see what I can do to get like close to that and use that as a starting point. But that also means that you could be very skewed and never be able to get there. So like you probably need to take like the distance between the biggest and the smallest number so that you know that you can still bridge that gap. Something like that. Because when I think back to like the buttons that I can press, and maybe it's interesting to just go back to my code here, and once again just skip solving the answer. Map all voltage outcomes 1. If I just dump all of this. Because as my brute force does greedy to a maximum number of presses, and if it fails, falls back to a BFS with DP. Yeah. That makes sense. Oh, wait. Boom. Let's not do the test here. False. Okay, boom. Okay. Like if we look at how efficient this one is, this just has one number that it doesn't press. And then I'm wondering like how bad, like there should be a way to figure this out. But like solving it in 2 ways seems difficult. Well, actually, yeah. I just wonder that if the search space would be like, okay, you could never get there by doing this, then how would you solve it? You could probably like divide the output by the mask of this, and when the ratios or the values are closest to the thing with the smallest outliers, you take that one, but that might not be the most efficient. Like here there's one where just 1 isn't counted, here's one where just 2 aren't counted. Here you have 2 options, and I wonder if you combine those, like the first and the last and these 2, so only these 2 in the middle would get more pressed. Actually, these are basically just bit masks, but that doesn't take into account the efficiency. Like I wonder if we start there, how much it would matter. But since like I don't think that taking a shortcut there would matter too much. Like the way that I'm thinking is like I could start halfway, half the search space, but half the search space is still a lot. Because I was thinking like I could take each one of those, and only the ones that have a 1, I compare them to all of them, and then the lowest number of those that it hits, take half of that, start off there, so that you at least have like a jump start while I try to figure out something smart to do. G says, oh, I'm just in time. However, I haven't done part 2 yet because I just got home, so I'm not watching this for now. Yeah, no worries, G. Part 2 is plenty of interesting for you to figure out. So, but always nice of you to say hi. Yeah, that's always appreciated. Hey, Sunco Software, welcome, welcome. It's a tough one today. I managed to write a solver, but it's not fast enough. So now it's a matter of, can we figure out a way to make it smart enough so that we can solve it? So basically, all of the code is done. It's I just don't have my quantum computer yet. So um, so yeah, that was just the only thing that I was thinking. Like, okay, can we just skip to the end most of the way? But then there are ones that have multiple best options. So would you then take all of them and combine them together? Um, which is probably what I would do. Um, I'm just trying to figure out what I want to do. Luke says, I think you really need math to do this. Yeah, I'm afraid of that as well. Um, but I thought that if I was able to at least cache some stuff, that it would be able to, like, that's usually magic for a lot of stuff. Just make sure that you can cache it. And I think I already have a somewhat efficient way of at least caching so that you don't care about the order. But even with the cache, there's still so many ways to get there. Yeah, I'm thinking about maybe just calling it a day and then doing some research on it, because I don't think I will get there from here. Because basically, I mean, the logic is all written. That's not the issue. It's the efficient one. Yeah, some button needs to be pressed 200 times. Yeah, I know. There's one that has a number of 285. So you know that at least 285 times you have to press that button, and then in combination with other things. So like the only thing that I have in my mind, but the thing is I don't know how to realize that, is that when I went back, I had all the combinations that you can press the buttons. So that if you can find like the ratio, like the GCD, something like that. Smap says, like a lot of others, I eventually went with the mass and an external library. Hashtag me too. Yeah, but something that I wonder is like, you should be able to factor something, but yeah, it's just annoying. Runs in just under 1 second on my machine. Okay. So I think we can conclude that if you don't know the actual trick, this is not gonna work. So I'm happy that I got it working for the test input, which basically means the logic is there, it's just like the optimization there. So I wouldn't even know how to call this. And I don't know how interesting it would be for me to start Googling this and then try to do it. So Gauss Jordan elimination. Okay, fine. So I think I'll make the decision to spend an hour with my wife tonight instead of streaming, and just call it a day for now, and just see if I find some time tomorrow to look at things. And maybe at the start of tomorrow's stream, we'll look at how I do this. Depending on how complex it is, if I can learn the algorithm and understand it, maybe I'll shift it over to tomorrow's stream to actually implement it and look at it and see if we can learn something from there. And if not, I'll just do it during the day probably. Smap says, I tried every search algorithm I learned in AOC and multiple optimization. I could still only work out a subset of the real data. Yeah, I can imagine. It's really complex. Okay. But now I might find a challenge in that, but yeah. So yeah, I think I'll end it here. I'll try to find somebody to stream, and I'll do part 2 tomorrow, maybe. Blakai says, I implemented also the non-Z3 library in Go with AI assistant. Okay. Not proud, but I'm not a mathematician. Yeah, okay. Marta says, your beloved hailstorm problem from the year 2023 P2 required almost the same solution. Yeah, go figure. Would have been weird if I was able to do it now then, right? Okay. Let's go see if there's somebody else that we can raid. Plus mid is still streaming. Let me see. So let's go raid plus mid. They raided us before. And let's go say hi, and then we'll resume this tomorrow. So yeah, thanks everybody, and yeah, let's go say hi. Bye bye.
Oh, thank you for the raid. NKCSS. Am Apparat, sehr gut. Did you manage to solve it? Hello, Raiders. Yeah, we are on Echoed of Codes day 10 part 2 in Go. And yeah, the scope keeps creeping. I'm already trying to optimize, although I didn't actually implement it yet fully.